Good morning. My name is Jenny Montblanc, and on behalf of the Great Basin Fire Science team and partners, I would like to welcome you to this webinar titled Fire Rehabilitation Effectiveness, a Chronosequence Approach, presented by Dave Pyke from the USGS Forest and Rangeland Ecosystem Science Center in Corvallis, Oregon. Before I introduce our speaker, I want to let you know that you may ask questions of the speaker or me at any time during the webinar by typing them into the questions pane of your control panel at the top right of your screen. I will keep questions for Dave in the queue and field them after the presentation. I will show up in your questions pane as the Wildland Fire Lessons Learned Center, but it's really me. I also want to let you know that whatever you do in your control panel does not affect the webinar presentation, so you're welcome to type a test message or test your audio at any time during the webinar. Now I would like to introduce our presenter. Dr. David Pyke is a plant ecologist with the USGS Forest and Rangeland Ecosystem Science Center in Corvallis, Oregon. His research focuses on the population ecology of native and invasive plants in the Intermountain West, with emphasis on restoring native plants on invaded landscapes. He also specializes in developing monitoring protocols for ecosystem integrity on wild lands. Welcome, Dave, and thank you for being here today.
Thank you.
I am making you the presenter.
I have control.
Yes.
All right.
Looks great.
Okay. Well, thanks a lot, and welcome. This is a talk that's really based on a collaborative project that a number of us have been involved in for several years. And many of you out there were probably involved by providing us information associated with fire rehab projects that you had on your lands, and even giving us information associated with that, and we really appreciated it. It started out as a project that was largely triggered through the Joint Fire Science Program as a question as to whether we could even accomplish this task. And we started out by doing a feasibility study to actually see if we could find locations where we had fire rehab projects that had at least adjacent to it locations that had been burned and unseeded versus burned and seeded. So when we talk about fire rehabilitation effectiveness, what we're going to be referring to in this particular, uh-oh, what's going on here? Is this on mine?
Yep, it is.
And why did that come up?
I don't know. You could probably just close it out, I would think, right?
We'll see if it shows up again.
Okay.
So we will we'll be talking specifically about seeding projects, ones in which after the fire the agencies have gone in and reseeded locations under the Fire Rehabilitation and Stabilization Program. And we chose projects where we could find both seeded areas that were close to or had within them unseeded locations for one reason or another. And then on the same soil we could find locations which had not burned and could give us a representation of what the ecological site associated with an unburned location would look like. Stemming from that work, we then, when we had a resulted publication that came out just recently this year, and this is the page of the publication, the long-term effects of seeding after wildfire, where the results that I'm going to be talking about today are published within that paper. Goodness, I've never had this come up.
One of our attendees said that if you hit the bottom choice, the pop-up won't show up again.
All right, we'll try that. And so anyway, we actually have more information than I will be presenting today in the paper, so if you're interested, take a look at that paper, and if you have any further questions associated with it, feel free to contact us. So let's get into it. The Emergency Stabilization and Rehabilitation Program, also known as the BEAR program in the Forest Service, really has three major objectives when a reseeding is being done. One is to reduce soil erosion. The other is to prevent invasive plant weed spread across the area. And the third is to rehabilitate critical habitat. With the revegetation projects that are being done, there are two general ways that these are accomplished. One is through using a seed drill, which for those of you who wouldn't be familiar with it, that would be very similar to farming practice of actually drilling the seed into the ground using a plow. And then the other approach would be through either a broadcast on the ground approach of putting the seed onto the ground or using an aerial broadcast technique. The thing that you need to recognize is that these programs, when they're put into play, really have some critical time frames associated with it. So those folks that have to do these projects and implement these projects certainly know the constraints under which they have to work with. The plans are, they have to put together the plan within 2 to 3 weeks after the fire is out if they're going to be doing stabilization work. And the whole work has to be done and completed either by 1 to 3 years out after the fire has been put out. So you're really under a lot of time constraints. You're under a situation that has particular kinds of goals that you're trying to achieve. And in many ways, this should not be equated to having direct restoration of a native plant community. So those need to be understood from the beginning. However, they can give us some insights as to information associated with restoration of many of these landscapes, even though they're not direct restoration projects themselves. Give you an idea of the impact that fire has across the Great Basin area that we were examining. These are the shaded area represents the sage-grouse management zones that are going across the interior Great Basin area. And the different color coding there are just different years at which fires have burned. And it gives you an idea of how many fires we have had and the extent that fires can have on these landscapes. And so when those fires burn, then they're having a critical impact on largely a lot of the sagebrush lands within the Great Basin. Not entirely just sagebrush, but it ends up being a lot of it being sagebrush land as well. And so this has become critically important for sage-grouse and many of the issues associated with sage-grouse because fire and invasive species have been one of the critical drivers listed as something that is potentially impacting the populations of sage-grouse. The other thing that we need to at least set the stage on is that with the multitude of plant communities that we have across the Great Basin, that there is, we already know from other studies that these lands tend to be more resilient with higher productivity. And that higher productivity generally is related to elevation and precipitation. And just diagrammatically here, to give you an idea, this comes from one of the papers that Jean Chambers led. And this has been a slide that she's used and others have used to sort of demonstrate this concept. But as you start to move from on the left-hand side of the screen, the warm, dry environments to the right-hand side of the screen being the cold, moist environments, you tend to go up in productivity as you go from a Wyoming big sagebrush site through all the way up to the mountain big sagebrush, mountain brush kinds of communities. So these communities down on this left-hand side end up being generally in lower elevations, lower precipitation areas with lower productivity, and as a consequence, we believe they are sites that are low resilience to disturbances and have low resistance to invasive species. In contrast, as you start to go up in elevation, have increased precipitation, we tend to move into the colder, moister environments with higher resistance and resilience associated with those. So for this study, like I said before, we tried to find locations where we had a multitude of projects where there had been a wildfire, there had been an emergency stabilization or rehabilitation plan that had been put into play, and a seeding project had been done on these lands. And we asked a series of questions that were related to these hypotheses, where we're comparing burned and seeded locations versus burned and unseeded locations. And these hypotheses are really looking at, if you do a seeding project, and if it's effective, we would anticipate that the perennial plant community should be greater in the burned and seeded area versus that of the burned and unseeded area. In contrast, if we're meeting the objectives of ES&R and we're controlling invasive annual grasses mostly on these areas, annual grasses like cheatgrass, then the annual grass cover will likely be less if we are effective with these treatments on a seeded area versus an unseeded area. Now, in our overall project, we also looked at the amount of exposed mineral soil, which would be related to erosion. We also looked at fuel loads and fuel continuity. I'm not going to be speaking directly about those two. The information associated with the mineral soil is in that paper that I mentioned at the beginning, whereas these other two are in papers, or in a paper that we're still in the works of developing right now. The last thing, though, that we'll talk about and I'll touch on today is effectiveness of these treatments truly greater on those lands that tend to be the more productive lands. And by that, we will define that as being the higher elevation, higher precipitation, low heat load types of environments on these landscapes. So how did we set this up? We actually had a large number of projects that we gathered. We gathered every single fire rehab project that was at every BLM district office across these major land resource areas in this northern Great Basin area. And from those, then, we evaluated as to whether they had areas that potentially could be fit into the set of criteria that we had. We wanted them to be spread across the 7 major land resource areas that are generally viewed as being the ones that are oftentimes most prone to having the wildfires and therefore most prone to having the revegetation projects. And then with the seeding treatments, we wanted them to have aerial treatments versus the drill treatments on them. And so some projects might only have aerial treatments, other projects might have drill treatments only, and other projects could have a combination of aerial and drilling. We wanted to get this spread of mean annual precipitation across these locations, and we initially tried to do that within each of the major land resource areas, but we quickly realized that one of the reasons why they are major land resource areas is that they actually differ in the amount of mean annual precipitation. So some of them might have fairly low mean annual precipitation, others might have higher mean annual precipitation. So as it turned out, we just made sure that across the whole scope of the 7 major land resource areas, we had as good a spread as we possibly could in terms of the mean annual precipitation within each of their major land resource areas. The second thing that we looked for was to try and get a spread in the ages of the ES&R projects. We went from having projects that were at least 5 years old or 5 years after the fire had been put out to projects that went to upwards to 20 years of age. And so these would be spread as best we could within each of the major land resource areas, but that greater spread between 5 and 20 years went across all of the major land resource areas. Another provision that we put into this was that we wanted to look at sites that had burned only once since 1970. And what we felt we would be looking at would be what happens on sites that had shrubs on them generally, and this would be the first fire since 1970, and so we would be looking at a fire that would have the kind of intensity and severity that one would have with a shrub grassland mixture. If we took areas that had burned twice, oftentimes those might be ones that portions of the area might have been burned only once and had shrub grassland mixtures, but the other portion of it might just be a grassland that had burned, and the intensity of the fire and potentially the severity of the fire would be different on those two. So we tried to keep it the same across all of them. We looked at loamy soils. We ruled out looking at clay soils, sandy soils, and we tried to just look at the loamy soils, viewing that these would be likely the more productive sites, and so therefore try and concentrate on those areas. And then we ruled out any location that had large amounts of pinyon and juniper on those areas to try and keep the pinyon juniper encroachment and the potential of that fire intensity, fire severity impact that pinyon juniper burning on the landscape might have. So largely we're looking at shrub areas, shrub grassland mixtures that have burned one time since 1970 and are between 5 and 20 years old on loamy soils that have a range in precipitation that would reflect this northern Great Basin area. So within the sites that we would select then, we would have burned areas and then unburned areas. So burned areas versus unburned areas. And within these burned areas, you could have a seeded area, such as this one in the lower photograph, and then an unseeded area. Uh-oh. Yeah. All right. I think that's just my screensaver. Within the unseeded area, we tried to have those as best we could within the actual seeded area. That would guarantee us of actually having locations that would have been viewed as being potentially needing seeding, but for one reason or another, they weren't seeded. It could be something like state lands that were nested within federal lands, and the state lands opted to not invest in the seeding effort, and so therefore that area wouldn't have been seeded. It also could have been a cultural site that wasn't seeded. So there were a number of reasons why those could be that way. With aerial seedings, we couldn't do that usually because the aerial seeding would be done across the entire area that was projected to be seeded, and so on many of those locations, those had to be directly adjacent to the seeded area, and so we tried to buffer those zones to ensure that we were outside of the seeded area. The unburned areas, of course, then were unseeded, but all of these were on the same ecological site. So the vegetation community should be roughly the same. The potential for those sites to grow plants that would have been generally the same kind of plant composition and the same amount of productivity on them. The seeding treatments, I said, were aerial versus drill seedings, and the overall project of what we actually selected and used in the study, 27 aerial-only treatments were used, 61 drill-seeded treatments were used. There were an additional 12 aerial over drill seedings that we used for other portions of the project, but for this particular study that I'm talking about today, we did not use those in the study. On each of these locations then, we went out to those sites. We randomly located a series of, within each site on a particular project, anywhere from 2 to 3 subplots. That would give us roughly around 813 total subplots across the whole study. And within a particular subplot, we collected cover information using line point intercept on the vegetation by species. We got the bare ground information at the ground level, and then we also had information on litter. I won't, like I said before, I won't be talking directly about bare ground, and I won't be talking about litter today. We'll talk specifically about the vegetation information. The way in which we did this was using the same kinds of treatments that the BLM AIM core protocol is. Along with this, we collected densities of plants by life form or by species, depending upon what we were looking at. And so this was largely for densities of deep-rooted perennial grasses, as an example, or densities of sagebrush would be an example of a species that was collected. All right, I'm going to spend a little time on this because this just tells you how to view the graphs that we are going to be presenting. So remember that if we're looking at effectiveness of an ESR seeding, we're comparing seeded versus unseeded areas. So if we have an effectiveness occurring, we're going to be looking for certain things to happen in these graphs. What you're going to see are oftentimes a series of lines that will be going across. On the x-axis, you're going to see elevation or precipitation. On the y-axis, it's either going to be cover or it will be density. And the reason why we're doing this is oftentimes our results showed an interaction between the treatments, the seeded versus the unseeded versus the unburned area, and an interaction then with the elevation or precipitation. Those tended to fall out quite often on these, and so that's why I'm spending the time on this, because what you end up looking at will be a series of lines that will be going across here with a confidence interval around each of those lines. Where the darker portion of the shaded area is, that's going to tell you that we have overlapping lines where we're going to fall in a situation where the seeded and the unseeded area is going to be roughly equivalent to one another. We can't be able to determine that they were different from one another. But as the line gets into the lightest of the shading of these two, so the lighter color, at this point where this line is here, these two lines then are diverging significantly such that the seeded area was significantly higher than the unseeded area. So in terms of cover of perennials across an elevation or precipitation gradient, we could say that at the point of this line where they diverge and both lines end up being in the lighter colored shading, it means that we had effectiveness for the cover of perennials. If it was ineffective, we would actually have both lines lying within the darker shaded area and no change between them across the entire elevational gradient. So in talking about our hypotheses then, for perennial plant cover, if perennial plant cover was greater in the seeded areas, that would be referring to information that would be important for controlling erosion. So like this situation here above this line, we're getting greater seeded perennial grass cover or perennial plant cover above this line, so potentially we would be effective for controlling erosion by having greater cover of the seeded species versus an unseeded area down here. Below this line, we wouldn't have that effectiveness. For invasive annual grasses, then, cover should be less in the seeded areas. By that, we would say then that if we've seeded those areas, we would expect that the annual grass cover would be lower in the seeded areas than the unseeded areas. So in those particular cases, we would actually have the seeded line should be below the unseeded line, and it would be in these lighter shaded areas. Sagebrush cover or sagebrush density would be greater on a seeded area versus an unseeded area, and that would be something associated with habitat structure for a critical habitat. So that's the way we will actually look at these for trying to interpret the information on the graphs. So let's dive into the results then. For total, let's start out with total perennial cover. And we're going to have a series of graphs that will always look like this to begin with. On the left-hand side, you'll have a column that will be associated with a particular variable, and the left-hand side will be aerial seeded. The right-hand side will be drill seeded for the same variable. Let's look first at total perennial cover. This would be cover of grasses and shrubs combined. For aerial seeded, the unburned area was higher than the burned areas for total perennial cover, but you can see that you don't have any overlap here, or no divergence of the seeded line from the unseeded line for aerial treatments. So not effective for total perennial cover on the aerial seeded areas. For drill seedings, however, once we start to drill seed these areas, what we find is that above about 11 inches in precipitation, these seeded areas then have higher cover, total perennial plant cover, than the unseeded areas. So that is showing that we're getting effectively more cover of seeded, on the seeded areas for total perennial cover than on an unseeded area for total perennial cover. Below the 11-inch precipitation area, these lines are not significantly different from one another. So the closer that you are to the line, you might get areas where you could have a drill seeding that might work well and have higher cover. But the further and further you get from this, in other words, the drier the site or the drier the annual precipitation on that site, the less likely you are to have a drill seeding actually have more perennial plant cover than an unseeded area that wasn't touched at all. Okay, how about just perennial grasses? If we look at all perennial grasses, well, once again, the aerial seeding is not showing any difference at all. But what about the drill seeding? The drill seeding is showing that the perennial grasses are showing a difference with the seeding, but that difference is at a little bit higher precipitation value on these drill seedings, so that our perennial grass cover is diverging from the unseeded areas for perennial grass cover at about 13.5 inches of precipitation. Below that, we're not having a significant difference. All right, we're going to tease this out a little more. Let's look just at native deep-rooted perennial grasses. This would be the equivalent of our blue bunch wheatgrass, Thurber's needlegrass, and so on. With aerial seedings, no difference again. Elevation increases, but there's no difference in terms of the deep-rooted perennial grasses on these areas. And these are areas that were seeded with deep-rooted perennial grasses. With drill seedings, interestingly enough, the native deep-rooted perennial grasses do not show a significant difference either. So the seeded bar is not significantly different from the unseeded bar in the amount of cover, and nor was any of that different than the unburned area in terms of the perennial grass cover on the unburned area. All right, many of these areas are seeded with introduced forage grasses. And so these are the non-native deep-rooted perennial grass cover here. We do get a significant difference in the, between the seeded and the unseeded areas for non-native deep-rooted perennial grasses, but remember that largely is being driven by the fact that the unseeded areas don't have any any of the non-native deep-rooted perennial grasses on them to begin with. So basically, is this significantly different from zero is really what we're testing here. And the seeded area becomes significantly different above 10 inches in precipitation. Below 10 inches of precipitation, we really are not getting a very effective stand of even the introduced forage grasses on these sites. Some may not, but over all of the projects we weren't getting that. With drill seeding, however, we can drop that level all the way down to 8.5 inches of precipitation. Above 8.5 inches of precipitation, our seeded area has significantly different amounts of perennial, non-native deep-rooted perennial grass cover. So we are getting increases here above essentially the 0 point. Below 8.5 inches of precipitation, you're really not getting anything different from zero. Now, if you remember when I talked about the total perennial plant cover, it wasn't showing much of a difference, but it was showing some difference with drill seeding. But the native perennial grass cover did not show a difference. And we started to wonder if we could find enough locations where we could run a comparison where we just looked at native perennial grass cover on areas that hadn't had the seeded introduced forage grasses along with them. So these are just projects. We only had 12 of them, but of those 12 projects, those areas that were seeded with only the native perennial grasses actually had twice the amount of cover of the unseeded area. So we got greater amounts of coverage of native perennial grasses when they were sown by themselves. So the thing that we're looking at here is the potential that the forage grasses are potentially outcompeting the natives when they're sown together. And I think that shows up actually by the fact that our total perennial plant cover really hasn't changed much overall. We get increases in the non-native perennial plant cover. We get no change whatsoever in the native perennial plant cover, but when we seed those native plants by themselves, we do get an increase. And so this is something that probably needs to have additional investigations on them, but I think that if our goal is to try and look at seeding native perennial grasses in many of these areas, we need to consider seeding them without the forage grasses in the mix. What about sagebrush? Unfortunately, sagebrush did not do very well in any of the seeded areas that we had. It never shows up as being greater than the unseeded. So for aerial, no difference between seeded and unseeded. For the drill, no difference between seeded and unseeded. And we thought, well, maybe for many of these, the sagebrush just wasn't large enough yet. Would we pick it up if we just looked at the densities? For aerial seeded versus unseeded, still no difference between in the densities. And same thing for the drill seeded areas. The densities of sagebrush were not different between these. So unfortunately, we're not getting a really good response associated with sagebrush on many of these ESR treatments. What about Forage Kosha? Well, this is one that's being used in a number of different locations. And sure enough, even with aerial seedings or with drill seedings, the seeded areas do, once again, this is another one where we're really testing against zero because the unseeded area wouldn't be seeded with Forage Kosha largely, although we did pick it up occasionally outside of the seeded area. And the increase with elevation, you get more cover with elevation. It's significantly different. The coverage was actually quite low, which sort of surprised me, but it was quite low. Same thing with the drill seedings. We get a little bit better coverage from drill seedings, but not appreciably more. And it increases with elevation as well. All right, what about controlling annual brome grasses? The cheatgrass mainly, but occasionally it was red brome on some of the areas to the south. So the annual brome species with an aerial seeding, our seeded areas versus our unseeded areas. For aerial seedings, unburned had greater amounts of the annual brome grasses. Our burned areas, our unburned areas had less than our burned areas, but there was no difference in the seeding. So our seeded versus unseeded really is not significantly different here with aerial seedings. With the drill seeding, however, above an area of 4,600 feet in elevation, we get the separation between the seeded and the unseeded, and the seeded and the unseeded. This higher line is actually the unseeded area and has higher amounts of annual brome grasses in it, and our seeded areas do have lower amounts. So it shows that we are effective at controlling the annual brome grasses, but it tends to be in those areas that are higher resilience, higher resistance to begin with. But it does show that we're getting less of those annual brome grasses with seedings on those higher elevations. Somebody asked me one time when I was giving a presentation on this, what was the effect of the ages of the, did age since time of seeding have any effect? And occasionally it did, but it had some interesting results. With aerial seedings, the total perennial cover actually was lower as age increased. And the perennial grass cover tended to be lower as age increased. I don't think that has anything to do with the projects. It was not necessarily, well, it was related to an interaction with elevation, because below a 5,200-foot elevation level, the cover of the perennial grasses was lower as age increased, whereas above that elevation, the cover was greater as age increased. So what we're finding is at the more arid locations, over time, we're actually losing perennial grass cover on these seedings. At the higher elevations, we're increasing perennial grass cover with age on a seeding. With drilling, the non-native, so introduced forage grasses, the deep-rooted perennial grass cover, increased as age increased, and that's what I would expect to see. You'd have an increase over time. This is the one thing that I'll talk about with bare ground. We found that bare ground also increased with age, and generally that was related to the reduction that we get in the annual brome grass cover. So as we lose the annual grasses in that area, we actually have the increases in the perennial grass cover, but we have an increase in bare ground on those areas too. So that's coming into play due to the loss of the litter associated with the annual grasses. So let me try and summarize some of this. What about with perennial plant cover? Our question associated with perennial plant cover, was it greater on the seeded areas? With aerial seedings, no, it was not. We had no net gain of cover over doing nothing at all. The higher perennial non-native cover occurred at 10 inches of precipitation, but it appears to decrease other perennial plant cover because the total perennial plant cover really was not different from that of the unseeded areas. So although you got higher forage grass coverage with higher elevation or higher precipitation, it seems to be offset by a reduction in other perennial plant cover, giving us no significant difference between the total perennial plant cover overall. With the drill seedings, we did see an increase above 11 inches of precipitation. The non-natives gained in cover, and their gain was essentially offset by a loss in the native plant cover, certainly at the lower precipitation levels in the drier areas. Above that, then the non-natives tend to provide more cover above the 13-inch precipitation. Native grasses sown without the forage grasses ended up having twice as much, and so it provides some evidence that non-native species, the introduced forage grasses, may be in fact suppressing some of the natives when they're mixed together in these seedings. And sagebrush cover did not differ at all between that of an unseeded area. Our ability to control cheatgrass and other annual bromes, was it reduced with seeding? The aerial seedings had no impact in terms of reducing the annual bromes on those areas. Drill seedings above 4,600 feet in elevation did appear to control more of the annual bromes on those areas, and bare ground tended to increase as that invasive annual grass cover decreased. What about the site productivity? And did effectiveness seem to increase with site productivity? And I think you could see that with most of those lines actually increasing as elevation went up and precipitation went up. Our effectiveness tended to show greater increases in cover associated with at least the drill seedings. The more resilient sites, the cooler, moister sites, were more likely to be the effective ESNR treatments. The less resilient sites, those drier, warmer sites, in the future, I think we need to look at having the more flexibility with ESR treatments to be able to go in and do multiple interventions on these areas, because it's really what you're up against is the chances of having a bad weather year for germination and establishment on those areas. So the final takeaways then, controlling spread of invasive annual brome grasses. Drill seedings are probably going to be the most effective, and if you're trying to do this on a low elevation or low precipitation area, you really need to have the ability to be able to go in and have multiple attempts at drill seedings on those areas in order to be able to offset the variations associated with weather. The perennial grass cover, the drill seedings are going to be more effective in getting greater amounts of perennial grass cover on those areas. Once again, the low elevation sites are probably you're going to need more flexibility in being able to go in and have multiple attempts at trying to put seed onto those areas. And I think we have to consider trying to do natives alone if we're going to use native species on these sites, because we're not showing that we're getting very good effectiveness of native plant cover when they're sown with the introduced forage grasses. And then sagebrush. Other research is indicating that surface seeding with compacting is probably one of the better techniques. However, we could not find within the plans projects that were doing this on many of these areas. It may be that those kinds of techniques are used on areas that have burned more than one time, but in the areas that we looked at, that was not particularly the case. But I think that's something that needs to be viewed more seriously if you're going to try and seed sagebrush on these areas. we really need to use the best practices for seeding, and it seems like the best practices have been surface seeding with compaction along with that. The other alternative would be to start looking at doing more with transplanting of sagebrush. And we only had a few projects that were transplanted. We couldn't really run a comparison on those, but there have been several studies that have recently come out, at least 3 separate studies that have shown successes with doing transplants with sagebrush. So I think that that's another approach that we should be looking for in the future. Well, let me give a big thanks to the folks at all of the BLM offices and their employees across that northern Great Basin area where we worked. Without your help and assistance, this couldn't have been done. We actually invaded many of your offices and spent a week or so there going through files and photocopying a lot of these plans. And you know, without your help, we couldn't have done it. The Joint Fire Science Program really requires a great thanks. This program, or this study, could not have been done without the funding that they provided and the insight that they had on it. The Land Treatment Digital Library was funded by BLM and USGS, and we really couldn't even have done this study if we hadn't had that capability of being able to put the file information that we found in the files associated with the projects into a queryable database. And now that we have that, we can do that. And then the whole host of employees that went out over the course of a couple of years collecting the data associated with this project. So I'll stop there and entertain any questions that you might have.
All right, thank you so much, Dave.
You bet.
Okay, our first question is from Bill Lutjens, and he asks, did the study stratification consider pre-burn ecological condition?
Good question, Bill. No, it did not. In many cases, we didn't have good enough information associated with the monitoring of all of the sites to know what those sites actually looked at pre-burn. It would have been nice to have had that. The best we could do was to use the unburned areas to get some idea of that, and the unburned areas we tried to find those on the same kind of ecological site, and if we had multiple grazing allotments, we tried to place those within the same grazing allotments. But there are many other factors that would be associated with that, and so it was not something that we could really be able to use as another stratification criteria. We did collect information on the cow pie counts in areas, and we're looking at that as a method of being able to try and get some idea of potential grazing impacts. We also are looking at the possibility of using distance from water as another way of being able to look at what could livestock have impacted some of these projects and the results that we saw as well. But that's been a tougher one to try and dig out.
Great, thanks. So I'm going to interject here for a second, Dave. So you said you're going to be looking at cow pies and possibly distance to water. So does that mean you'll have those results coming out? I mean, that's something you're doing for a paper soon?
Yeah, it'll depend upon whether we can actually get good enough information to be able to use that. But,
gotcha.
It is one of the things that we will look at, and we have interest in using the structural equation modeling approach to try and get an idea of what factors are influencing some of the results that we're getting here. So using some more statistical approaches and modeling approaches to try and get at that.
Okay, great. Thanks. All right, Ryan Shane asks, for the precipitation breakpoints for seeding effectiveness or significant difference, are these values coming from annual precipitation the year following the seeding? Did you look at analyzing against the precipitation occurring January to July, since this has the greatest impact on seeding effectiveness?
Yeah, that's a good question. We did look at that time period. And we ended up using the annual precipitation largely because that's a predictive factor that anyone could use. We've had some discussions with Stuart Hardigree with ARS in Boise, and Stuart's been working on the development of some weather information and how that would relate to establishment of seedings. And so we may be able to go back into this data set and actually tease out how important that actual year's weather was to the successes that we saw. And that would be a really interesting thing to be able to tease out. You know, if it really is the whim of whatever the weather was for that particular year, that becomes a very important factor. And I think that it's one of these things that I think we have to reevaluate in terms of the ESR policy that restricts how often you can go in and do these kinds of studies. If we're going to try and work in these more arid environments, we have to be able to have some flexibility to deal with some of the weather parameters that really impact our successes.
Yeah, that would be great. We look forward to that information. Lee Turner asks, what effect does domestic livestock grazing have on the perennial plant cover seeding failure in this study? I think you touched on that a minute ago, but if you want.
Yeah, we really, like I said, I don't know that we can tease that out. We've looked at it a couple of simple ways, and it's not as simple as what we had hoped. You know, it wasn't merely going in there and being able, well, number one, we don't have good utilization information, and we're going to try and get the information on at least the timing of grazing. But the problem we've run into, we meaning the bigger research group as a whole have run into with this kind of a study in the past has been that when livestock grazing comes back into these seedings, it can actually happen earlier in a seeding that has been a failure because they're trying to get the livestock back onto this area early enough to keep the cheatgrass cover low. And if cheatgrass is the only thing on that area that has come up, then it becomes a fuel control mechanism, and we might just as well go ahead and graze those areas. So merely the time at which livestock grazing has been turned back onto an ESR project, it can't be looked at alone. You really have to look at it in terms of how successful was the seeding to begin with, and then when was the livestock grazing returned on that area, and then what kind of livestock grazing. So I think that's going to actually take a couple of different studies to actually begin to tease out some of those impacts. It's not as simple as it might sound.
Okay, thanks. I think you answered Lee's next question, which was, is there any way to tease out the effects of precipitation in the year following the seeding rather than looking at the average annual precipitation at the elevation of the seeding?
Yeah, well, we can get the climate folks to be able to get better predictive models ahead of time to where they can tell us in the fall what the precipitation is going to be in the winter and spring. That would help. And I say that jokingly, but I don't think we're all that far away from being able to make some of those kinds of projections. It becomes more difficult in the Great Basin than it does in a lot of the environments just because of the fact that as you get into areas that are away from the coast, our predictability of things that are associated with these larger climate events like the northern decadal oscillations and the multi-decadal oscillations in the Atlantic, both the Pacific Ocean and the Atlantic Ocean are used as predictive factors. They do a better job of predicting what the weather is going to be to the west of the Cascade, Sierra Nevada front. As soon as you start going over the mountains, however, we get less predictability over there. They're doing better at getting better predictions, but we're not quite to that stage yet.
Lee said seances and Ouija boards.
There you go.
All right. Eric Ellis asks, were all of these treatments seeding only seeding only without herbicide or other weed treatments?
As far as we know, they were. We teased out the information from the plans, and generally, if it had other factors that were associated with it, then we didn't. Those areas were oftentimes ruled out. And largely we did that because the largest number didn't have any kind of herbicides associated with them.
Okay, thanks. Rob, I don't know how to say your last name. Feigener? I'm sorry. Anyway, Rob asks, was cheatgrass reduction at higher elevation mechanical from the disc or from competition from seeding?
I think that it has to be from competition from seeding, or at least it's not just from the disc. If it was just from the disc, I think we would have seen it at the lower elevations as well. And so, you know, in the short term, you might have a reduction that might be associated with disking, and with the discs that are associated with a rangeland drill, that's more likely to occur. But I think that you know, when you start looking beyond 5 years, 5 to 20 years after a seeding, by that time cheatgrass populations have gotten back up to where, you know, merely burying the seed that was adjacent to your drill row is probably not going to be showing up as a major factor any longer. And so I really do suspect that it's a true competition effect that we're seeing that's associated with the seeding at those higher elevations and higher precipitation.
Okay, great. Well, thank you. That was the last question.
Okay.
Yeah, so let's see, to the audience, we would greatly appreciate it if you would take our 3-question survey of this webinar that will appear after the webinar has ended. And a recording of this webinar will be sent to you automatically through the GoToWebinar system tomorrow, but we'll also have it posted on our Great Basin Fire Science Delivery website within the next couple of weeks. And if you have more questions regarding this webinar or have requests for future webinars, please email or call me anytime. Thank you all for your participation today, and thank you, Dave, so much for your presentation.
Thank you.
All right, have a great day, everybody.